This is PreCalc 11, Chapter 1.2. We're going to be looking at Arithmetic Series. And this is the sum of a finite number of terms of an arithmetic sequence. This is represented by Sn. If we have Sm such that m is less than n, then this is called a partial sum. And recall the notation here. N is an element of the natural numbers starting at 1. Here's an example. We have an arithmetic sequence, 5, 7, 9, 11, and so on. If we take n is equal to 4, we are calculating S4, and that's 5 plus 7 plus 9 plus 11, and that equals 32. If we calculate S3, this is 5 plus 7 plus 9, that equals 21, and we call this the partial sum. Now, if n is small, it's easy to calculate the arithmetic series. However, if it's large, this would take a long time. So what we would like to do is find a formula. Let's start off with S4. Now let's rearrange S4, and we'll do it backwards. And the reason for doing this is to spot a pattern. And we can rearrange it because adding is commutative. If we add both of these up, we have 2 times S4. And we have 5 plus 11, 7 plus 9, 9 plus 7, and 11 plus 5. So 2 times S4 is 16 plus 16 plus 16 plus 16. Now looking at it in this form, it's much easier to calculate. So S4 is equal to 4 times 16 all over 2. We have to divide both sides by 2 since there's a 2 out front. And this is 64 divided by 2, and that's 32. And we get the same answer, which is a good thing. So the general formula is Sn is equal to n times t1 plus tn, all divided by 2. We can see our n from there, and we can see our 16 from here. It's t1 plus tn, and t1 is 5, and t4 is 11. And we just carry the 2 down here. So that's how we come up with the formula. From here, we can create another formula. Sn equals n t1. Now, from chapter 1.1, we know what tn is. This is t1 plus d times n minus 1. And we have our another formula. We can simplify this. And this is the formula that we'll be using. Now, when you're solving problems, don't choose a random equation. You have to look at what information you have and what's missing, and then choose the right equation to work with. Okay, here's an example. T1 is equal to 5. T8 is equal to 33. Determine S8. We use the first equation because we have all the variables. We don't have D, so we don't use the second equation. So S8 equals 8, that's n, times T1, which is 5, plus T8, which is 33, and we divide it all by 2. 8 divided by 2 is 4. And 5 plus 33 is 38. And this is 152. And we use the first equation because we don't have D. Okay, next example. We have Tn is equal to 7 plus 3 times n minus 1. And we need to determine S7. We're going to use the second equation because we don't have T7. So S7 equals 7, that's our n. Don't confuse that with this 7. And we have 2 times 7, which is our T1. T1 is 7 because plug in 1 here. We have 1 minus 1, that's 0, so we're left with 7. We plug in our D, and our n is 7, and minus 1. And we divide everything by 2. Now we simplify. This is 7 times 14 plus 3 times 6. That's 18 all over 2. So this is 7 times, this is 32, and divided by 2, 32 divided by 2 is 16. And we end up at 112. Now, we have backwards problems where we're given Sn, and we're given some other info. We have to determine what the missing info is in order to use the right equation and plug in our known values. So we have S10 is equal to 380. We know T10 is equal to 45, determine T1. So this doesn't involve D, so we use our first equation. And the first equation again is this. So plug in everything, 380, n is equal to 10. And we don't know what T1 is. And we have T10 is 45. And we need to do a little bit of algebra. So this is 10 divided by 2 is 5. So we need to divide this side by 5. 380 divided by 5 is 76. And we have T1 plus 45. T1 is, we need to bring the 45 over to the other side, so that's negative 45. So 76 minus 45, that gives us 31. And that one's done. Let's look at the next problem. Okay, this time we're given D, and we're not given T15. This means we need to use the second equation. So let's write that down. S15 equals N So write out the equation first until you get used to what the equations are. Now put in our known values. And n is 15. And we don't know what T1 is. And n is 15 again. We need to multiply this side by the reciprocal of 15 over 2. So this is 495 times 2 divided by 15. And that works out to 66. And on this side, we have 2 times T1 plus 5 times 14. That's 70. Now we need to move the 70 over to the other side, so that's negative 70. That gives us negative 4. Now we need to divide both sides by 2, and that gives us T1 is equal to negative 2. And we have a couple more examples to go through. We have S8, we have T1, and we're asked to determine d. Since equation 1 doesn't have a d, we have to use equation 2. Okay, so let's write out equation 2. And we don't know d, so we just fill in d. And plug in our known values. Okay, 8 divided by 2 is 4, so we need to do 56 divided by 4. So we have 14. 2 times 4 is 8, and d times 7. So 6 is equal to 7d. So d equals 6 divided by 7. Again, d does not necessarily have to be an integer. It can be any real number. Here's a slightly harder question. We're just given this. We don't know what n is. So we need to go back to our formula in chapter 1. Tn equals t1 plus d times n minus 1. Now plug in our known values. We know that our last term is 86. We know our first term is 17. We know that d is 3 because we can see that it's increasing by 3. And we have n minus 1. Bring the 17 over to the other side. That's negative 17. This is 69 equals 3n minus 3. We bring the negative 3 over to the other side. It becomes positive. So that's 72. And we divide both sides by 3. And that gives us 24. Now we know what n is. We can use our formula. We can use either formula in this case, but it's easier to use the first one. So we have S24 equals 24 times T1, which is 17, plus T24, that's 86, all over 2. So this is 12. 24 divided by 2 is 12. And we have 17 plus 86, that's 103. And this equals 1236. And I'd like to thank Orion for pointing this out to me. I had a mistake here. So this is a little bit of work, but it's far easier than adding 24 numbers together. And imagine the amount of time you'd save if we were adding 200 numbers together. So it's best to use the formula. And that completes this lesson.